Okay, hello. So in this video we're going to look at transformations of graphs. Now this is a tricky topic and there's a lot to think about. So what I suggest is you watch a video and maybe you need to watch it more than once. Ideally you can understand the logic behind each of these transformations, but if you find it difficult, in the end you can just learn them. But it's important that you can either work them out or you learn them, because it will come up. This comes up, it always comes up. Okay, so let's look at the first one. We have y equals x squared, so that's f of x, that's our function of x, and we're just going to add 2 to our function of x. So what we do is whatever it was before, so here it was 0, we're going to add 2, so our y value gets bigger by 2. 0 plus 2 gives me 2. So where it was 1, I add 2 to it, it'll now be 3. And where it was 4, I add 2 to it, and it will now be at 6. So hopefully you can see that what we've done is we've just moved every point on this graph up 2. So when we add 2, it moves the graph up by 2, and that's called translation. We haven't changed the shape of the graph, it's all as it was. So more formally we write y equals f of x, because we haven't done anything to the function's remained exactly the same, plus or minus a, where a is just a number, causes a transformation by a units parallel, so parallel to the y-axis. We move up or down by 2. So this time we have our transformation inside our function. So we're going to change the x. So this time we're going to make the x 2 smaller. So we have to work out what that does. So what we think about is, say, if we had x equals 3 here, what value of x would I need over here to get the same answer? Well, I'd need all of that there to equal 3. So my x would now be 5. So my x would be 2 bigger. If this was 7, what value of x would I need in here? I would need 9, because 9 take away 2 would be 7. So it would be 2 bigger. So all your x values move across by 2, and they move to the right by 2 when you're subtracting 2, because you need more x values now than you did before, because you have your x value and you've taken some away. So to get the same answer, you now have to have higher x values. Of course, if we plus here, to get the same y value, you would then take away from your x. So if this was plus 2 and we had 7 here, we'd now only need 5x. 5x plus 2 would give me 7. So we would then move to the left. Now this is slightly counterintuitive, and people think that when you add you're going to move to the right, and when you subtract you're going to move to the left. It's the other way around. So when you take away you move to the right, and when you add you move to the left. You just need to, if you can't work it out and see why, you just need to learn that. So if we have a function and we add or subtract something to that function, we move parallel to the x-axis. So this time we're moving that way, or oops, that way, and we move left and right, and we do it in the opposite direction to the signs. Okay, so when we have minus our function, so we're not changing our function at all. This minus is outside of our function, so we still just got x squared. The change is outside the function. What we do here is whatever y answer we had before for a given x, it will now just be minus. So where it was plus 4, it will now just be minus 4, and where it was plus 1, it will now just be minus 1. So whatever answer we got before, we now change the sign, and hopefully you can just see that that's a reflection in the x-axis. So everything which was above the line will now go below the line, and if there was anything below the line before, it will go above the line. Okay, so this time we've got the change inside the function, so the minus is inside the function before you do the cubing. Okay, so what happens here? So really what you need to think about is, to get the same answer here as here, my x must now be the opposite sign. So here, this was positive before, If I want the same answer and have this positive now, I now need minus 2. So if this was 2 there, I need minus 2, minus and minus is a plus, to get the same answer. So whatever x value you needed to be on this side, you now need minus it to be on the other side to get the same y answer. Okay, so what this does is swap whatever's over this side over to the other side, because you're changing the sign of the x as you're putting it in. So you get whatever answers were on the left-hand side on the right now, and on the right on the left. So this is a reflection in the y-axis. Okay, so this one, it's one I think is relatively easy to understand. We're stretching up. So we had x squared before, and our change is outside the function, so we're just going to multiply our function by 2. So whatever the answer was before is now 2 bigger. So if the answer for our y was 1, it's now going to be 2. And if our answer for y was 4, it's now going to be 8. So every answer is going to be twice as big, so it's going to grow higher faster. And so this is called a stretch parallel to the y-axis by a scale factor of a. So by y, whatever you're multiplying by here. So if I had 5 here, every answer would be multiplied by 5. Okay, so let's have a look at this one. This one is slightly difficult. Let's see if we can get to the end of it. If we have y equals x squared, now this time we're going to multiply inside our function. So we're going to change our x value, do something to our x value before we square it. I'm trying to think what this will do. So if we had here x equals 1, what x value would I need now to get the same answer? I would need x equals a third. So my x value has got smaller here by a factor of 3. If I had x equals 3 here, to get this to equal 3, I now only need x equals 1. So my x has got smaller by a factor of 3, because 3 divided by 3 would give me 1. If I had 6 here, what x value would I need here? I'd need 2. And so again, my x value has gone from 6 to 2, so it's got smaller by a factor of 3. So what's happening here, we have a stretch parallel to the x-axis by a scale factor of 1 over a. So that sounds a bit weird. So what we've done is compressed our x values. We need less of them more quickly, and they reduce, each x value is reduced by a factor of 1 over a, or 1 over a third in our case here. So this is tighter together here than it was in this one. Okay, so that one is the last one. I hope they help. You need to try and get this sorted out in this module, because when you get to the next module, you have more than one transformation going on. So if you need to go back and think about them, then please do.